Good morning to all. Today we are going to discuss about basics of semiconducting materials. Semiconductors. Based on the electrical resistance, the materials can be classified into three types. One is conductor, semiconductor, and insulator. If a material is semiconductor, then their resistivity should be in the order of 10 power minus 4 ohm meter to 0.5 ohm meter. Then the energy gap in between valence band and conduction band should be greater than 1 electron volt or approximately equal to 1 electron volt. Semiconductors are essentially can be conditioned to act as good conductor or good insulator or anything in between. Depends upon the physical conditions. The semiconductors can be behave like an insulator or conductor. The common elements such as carbon, silicon, and germanium are the semiconductors. Silicon is the best and commonly used semiconducting materials till date. So, what is the structure of semiconducting materials? When we see those materials we have seen in the last slide, carbon, germanium, silicon, they have four valence electrons in the outermost orbital. We know that 14 electrons are there in silicon. You see the orbitals, the outermost orbitals have four electrons, and each electron is combined together with covalent bonds. So all of you know that what is covalent bond? It's a sharing of electrons. So these are the general properties of semiconductors. They are formed by covalent bonds, as we discussed earlier. They have an empty conduction band at 0 Kelvin. They have almost full valence band. They have small energy gap and they possess crystalline structure. They have negative temperature coefficient of resistance. If the impurities added to a semiconductor, its electrical conductivity increases. Similarly, if the temperature of the semiconductor increased, the electrical conductivity will be increased. When you see the periodic table, there are different kinds of semiconducting materials. There are two types. First one is elemental semiconductors, then compound semiconductors. You see this periodic table. The elemental semiconductors, these are made from single element or fourth group element of a periodic table. They are also known as indirect bandgap semiconductors. When you see this fourth group, carbon, silicon, germanium, they are most commonly used semiconductor elemental semiconductors. You can see their bandgap structure. Next one is compound semiconductors, which are formed third and fifth group of elements, or second and sixth group of elements in the periodic table are known as compound semiconductors. These compound semiconductors are also known as direct bandgap semiconductors. You can see the direct bandgap here. The electron transition from the top of the valence band to the bottom of the conduction. Whereas in the case of elemental semiconductor, the electron transition is not a linear process. They can see when you see the momentum and energy diagram. The top of the valence band and the bottom of the conduction band is somewhere located. So the electrons cannot be traveled directly from the top of the valence band to conduction. So these are the examples for common semiconductors: gallium arsenide, indium phosphide, or indium arsenide, and magnesium oxide, and magnesium sulfide, zinc oxide, and zinc sulfide. So semiconductors can be insulators. How it can be insulated? If the material is pure semiconductor like silicon, the crystal structures form an excellent insulator since all the atoms are bound with each other through covalent bond. Hence, there is no free electrons. If there is no free electron, then definitely there is no current flow. Good insulating semiconductor can be referred as intrinsic semiconductors. Why we are calling these intrinsic semiconductor? Due to the involvement of their own electrons in the conducting process is called as intrinsic semiconductor. Since the outer valence electrons of each atoms are tightly bound together with another through covalent bond. So it is very difficult to dislodge the electron from the covalent bond to make free electrons. Silicon in this form is greater insulator. Semiconducting materials are often used as an insulator. Types of semiconductors. So as we discussed earlier, there are two types: intrinsic semiconductors and extrinsic semiconductors. So intrinsic semiconductor without any addition of impurities, which means their own electrons can involve in the conduction process. How they can involve in the conduction process? We need to increase the temperature. When you increase the temperature, the thermal energy can break the covalent bond and they can make more number of free electrons. They can move freely from the top of the valence band to conduction, bottom of the conduction band. Therefore, there will be a electricity flow, current flow. We can call it as current flow. After 0 Kelvin, the band is completely filled and conduction band is empty. So that is what we used to say that the intrinsic semiconductors at 0 Kelvin, they can behave like an insulator.